Year 11, we're back here again. We are looking at some other graphs now. We've looked at straight lines, we've looked at quadratics or parabolas. We want to look at some special cases here. Now, to some extent, you've only got to remember some particular versions of these because they do get a bit complicated. Okay, so first of all is a cubic. So something like y equals x to the power of 3. If I have plus some x squareds and x's and whatever else, bit too complicated. Okay, a bit too complicated. All I really want you to remember is what y equals x to the power of 3 looks like, right? And it's sort of a bit like a parabola, but the bit on the left-hand side, the negative part of it, right, the negative x's, has been flipped over, right? Because if I, right, all of a parabola is positive, the y values are positive because I square a negative number, I still get a positive number. But if I cube a negative number, I get a negative again. Okay, so we have a negative part here. We have this sort of thing, and it means that our domain and range revert back to all real x and all real y. Okay, there's limitations on the range of a quadratic, but not on a cubic. There we go. So that's a cube. Next up, a fourth power. A fourth power, so x to the power of 4. Right, it's a lot like a parabola, but if I was to draw a parabola on here, it would look like this. It would be wider out here. Right, it would look something like that. You see that? Something a little bit like that. As I increase the power, these sides become steeper, and it becomes sort of flatter at the bottom. It becomes more beaker shaped. If I did y to the power of 6 in there, it would kind of look a bit like this, perhaps. Right? That might be y to x to the 6 and y equals x to the 2. Right? Maybe it would look something like that. Something a little bit like that. Right? Passes through the origin. It has a domain of all real x, but a range of y is greater than or equal to 1. Okay? That's the fourth power. Now this one here, y equals the square root of x. If I squared both sides, I would get y squared equals x, which is sort of like a parabola, but flipped around, x and y flipped. That's sort of what's happening. But I've got to remember that this symbol here means the positive square root, right? So if y was equal to 4, x doesn't equal plus or minus 2 by this thing. This is y equals 4, x equals 2 is the positive part of it. Okay, which gives me this sort of curve here, like half a parabola, but all positive. Okay, because I'm just after the positive bit, like a parabola on its side, but just this positive part. If I did the whole lot, if I said y squared equals x, then this part would come in here as well, right? I would get this thing going on, and that would not be a function, right? Would fail the vertical line test, but we're not after that. Okay, we're just looking at the positive square root, right? Remember this, like a parabola on its side, but only half of it. If I had negative, right, if I just asked for the negative part, well, it would be this part down here. Next up, circles and semicircles. These are wonderful. Now, if you see something like this, x squared plus y squared equals some other number, that's a circle, centre at the origin, and a radius of, well, the square root of that constant there. Now, sometimes we rewrite that, right? I rearrange this. I'll put the x squared over here, so I've got y squared equals a squared minus x squared. Then I take the square root, and I just take maybe the positive part. Right? If I do this, then I just get this semicircle here. Right? That's the positive square root of a squared minus x squared, where a is the radius. We're not shuffling it away from the origin for the time being. Right? A is the radius. Right, so we've got a squared in there. Right, that's the positive square root, that's the negative square root, a semicircle. Right? A circle itself, not a function, right? Fails the vertical line test. This one, these are functions because they pass the vertical line test. Good? I'm going to run those out. So that is, we've looked at cubics, right? Cubics go like this. Fourth powers go like this. Square root goes like this, and circles and semicircles. Okay, you just got to become a bit familiar with those. Look at them a couple of times. We'll look at some examples. At this stage, it's mostly just seeing it, recognising it, match that equation to that graph. Now, here's an example of the sort of thing we might be asked to do. What is the shape of this? right? Square root. Want a square root of something, right? Not just the square root of x, square root of something minus x squared. That's a circle. It is a semicircle. Semicircle. Lower half. Center at the origin. Right, a 0, 0. Right, that's because I don't have the x's and y's in brackets with other things there. Center at the origin, radius, square root of 9 is 3, radius of 3. Okay, that's what the shape that is. What is the domain and range? Well, it looks something like this. The domain. What x values could go into that? Well, it's from x is negative 3 across to x equals 3. It can't be over here, it can't be over here. So I'm going to say negative 3 is less than or equal to x is less than or equal to 3. That's my domain. My range, not quite the same. If it were a circle it would be, but this time there's no positive y in this. In fact, because whatever I put in here, once I take a square root, I'm making it negative. My square root has to be positive because, well, in fact, we've defined that it's the negative square root. Let's just leave it at that. So it's all negative here, but it could go from negative 3 is less than or equal to y is less than or equal to, and it is or equal to, it can be all the way up to that, less than or equal to 0, right? Semicircle, it just goes up to the x-axis. That's the domain and range of that semicircle. Now you could have a look, you could check any of these numbers that fit within that bracket, if they fit in there, and you will find a matching value. You will be able to solve that equation if you substitute anything that fits within those those bounds. Substitute any of those in, try to substitute something else in, try to substitute y equals 1, not going to work. Try to substitute y equals 4, negative 4, not going to work. Righto, domain and range, a few special graphs. Okay, see you in class.